Thank you very much for your interest in our talk, How to Integrate with Real Cars, Minimizing Lead Time at Volkswagen, especially at Volkswagen Commercial Vehicles. I'm Michael, I will give the introduction, and for the nitty-gritty details, I will hand over to Jan. Okay, let's start with the introduction. As you probably know, we are a B2B brand, Volkswagen Commercial Vehicles. We started with the Bulli, which we offered for B2B customers, but we really became famous for offering this car to B2C customers, using it for their own purposes and things. So our next big thing, stemming from the Bulli, is the ID. Buzz. It will be our next flagship. It will be released next year and will drive autonomously by 2025, which is really a great objective and a big goal for us. And we are really proud of this car, and it will have a lot of software inside. So the big four trends, which have a big effect on the automotive industry, they are abbreviated with ACEs: autonomous driving, connectivity, electrification, and shared mobility. And autonomous driving is therefore liberating time, for example, for our customers, probably 1 hour per day, where they have not to concentrate on driving, instead being able to do other things. Connectivity means that we will offer mobile online services trying to improve the customer experience for our customers at the touch points. Electrification, meaning that we try to reduce the CO2 footprint of our cars to good things for the environment. And shared mobility means that for the next generation, owning a car is not so important as being able to move from A to B. So as you see in this slide, is that the automotive value chain is changing by these big four drivers, introducing new steps and phases in the automotive value chain, like, for example, mobile online services. And this means that it's not as in the old world that you produce a car and sell the car, and then the car is used by the customer. Now we have steadily a touch point to the customer by having this mobile online services. And these can be different services. And in the B2B field, it's, for example, fleet management solution, where we've worked on over the last years and many thousands and 100,000 lines of code, like, for example, offering an online logbook. But the next big complex software project that we are currently working on is predictive maintenance. And this is for maximizing the uptime for our customers. That, for example, we are able to predict failing components before, in order to improve the uptime for our customers, so they have always a fully operating fleet which they can use to earn money, which is the most important for them. And now I hand over to Jan for the details.
Hi everybody, my name is Jan Kantert, and I will talk you a little bit about what our challenges and solution is. So what Michael already motivated is that the amount of software in our vehicles is changing. So if you look like Boeing 787, it has like 14 million lines of code. I mean, it's a management overview, so it's very roughly estimated, I guess. And for a modern car, we estimate like 100 million lines of code around all the ECU, like the ABS to the HMI, the display in the car, to safe driving abilities, the back end, and with everything. So there are some comparisons here where how much software is estimated to be at certain companies. For example, Facebook 60 million or Google at 2 billion. So how does this typically work at Volkswagen? So when we create a product, some product owner starts like writing some requirements. And then there's usually some supplier which then implements this. So it's not that Volkswagen traditionally does write software. So we got suppliers for that. So the supplier commits all the code and afterwards hands over like the software like 2 years later, for example. And then the approval stuff, the functional approval and the integration happens at Volkswagen again. That's the traditional approach here. And for that, the supplier takes the warranty for all the software. And usually he also may be a different supplier, but some supplier usually also operates the software. So that's also not done by Volkswagen. But as you can imagine, that probably will not work in the future. So for all this autonomous cars, we have to get into the software development business somehow. And that's an issue here. Like if you want to commit into this repository from the supplier here, he will say, well, no, you cannot, because I take the warranty for that. And if you develop code and commit it, then I will no longer do that. And I can no longer ensure stable operations if you also develop code. So this happens at multiple like software products, and they act like every supplier acts like a different company, right? So those are totally separate. And if one product wants to talk, or if one development team wants to talk to another development team, this usually goes through product management. They talk with the other product team, and then they give this to their supplier. And as you can imagine, this communication chain is long. So what we changed in the beginning is that we did not just we requested from the suppliers that they do pull requests, like in modern software development, right? And that somebody internal at Volkswagen with technical knowledge, so we hired the right people, that they review the code. And we also had another reviewer from the supplier, so that we internally gained knowledge about our own software, which is good. And then we at some point said, well, yeah, we will take the warranty of the software. I mean, it makes sense if you sell the software that you also take warranty for it. And we also took over operations. So our internal operations team took over the software, which helps to understand software, right? Because you want to measure KPIs and so on. And that definitely works better if you operate it on your own. So we had some help from suppliers in the beginning, but by now we run it completely internal. And then at the end, so we closed the gap below. So we started to use a central code repository. As you can imagine, Volkswagen is a large company. This is still an ongoing process, but at least in certain areas, we built a shared code repository where technical people could actually collaborate, so they can share code and reuse stuff, which they usually want, but couldn't before because they just worked separately. And what this did to us is we measured it a little bit. We did this for like 1.5 years now, maybe 2 years. And we measured like how did the cost change and compared to the output. And like it's hard to measure output for software, right? So what we measured is lines of code, which is like a surrogate for like the actual development, right? So we measured like the speed of development. So how much code did an average employee write? And then how much the stuff costs. And actually the stuff cost increased because internal people are a little bit more expensive than external suppliers. But the speed of development increased more than the cost increase. So for us, it's like a net 23% cost advantage over outsourcing, which is really great. We didn't expect that in the beginning. And in addition, we now, at least we estimate that our quality is better because we got less bugs, we are faster in integration, and the internal people actually take responsibility and ownership for their own product. And you build software for somebody else, you throw it over a wall, and the other people that then use it, then you're not taking responsibility. So that works better with internal people. So yeah, let's go a step back for a minute. So this is the development process, the software development process at Volkswagen, which is derived from like the car development process. So you got an idea. First, you set the scope, you set up financing, get approvals. Then you typically run like a tender where you get the cheapest supplier or best supplier, depending on your criteria. Then development starts, and like a year or two later, you get the software thrown over a wall. And now integration at Volkswagen starts. So we take real cars, drive them around the world, and test the software. and then there's like a formal approval and quality assurance process, and eventually the stuff goes live. And this typically takes like 5 years and has certain assumptions, which is like development is always outsourced, development ends, which is like problematic if you develop an app. I mean, it makes sense if you develop a brake, it's sometimes done, then it can be built and produced, but it's not that great for software. And integration always happens by the original equipment manufacturer. So that's basically what those large companies then do. And if you measure this with the lead time, then we got like the first step is requirements hardening, where we write our requirements and refine them and compare, for example, with customer needs. Then we do like system design. So how do we do it? Which team does it? Where do we do it? How is this connected to other systems? How does stuff interact? Then the actual work starts with usually a supplier. And then at the end, there's integration. And in this chain, integration is typically the time which is the longest, because there's all this testing, then it has to be approved. There are usually a lot of bugs, because that's the first time where stuff interacts, and then you get issues. And overall, that's basically the sum of all of them is the lead time. So why do we need this crazy process? So the reason for that is like there's certain regulation if you want to build cars which then move people. And that's, for example, ISO 26262. That's about car safety, which says like if you got an ABS system, it has to react within a certain hard real-time requirement. There's ISO 21434. That's like the new cybersecurity stuff, where you have to make sure that the stuff isn't hackable. And then the standard stuff, ISO 2701, for all the general IT and information security stuff. And this requirement is usually harder for the stuff inside the car than outside the car. So for a web app, there's still some requirement left, but it's much less than, for example, for an ABS system. And if you look at the development cycles, that's on the right, you also see that those development cycles for a web app can be like few weeks or a month, but for an ABS system, it's really it's years, because it requires a lot of testing. Every change has to be formally verified and so on. So what can we do to improve this process, right? So I mean, we cannot entirely get rid of it because of the regulation, which is a good thing in general. But how can we get faster when we want to release software? And one of the things we can do is we can interleave the processes. So we can try to do stuff in parallel. Obviously, testing, I mean, that requires that the software is written or has been written before. So there are some dependencies, but we can parallelize certain things. And then we can do like early integration tests that usually helps to get fast feedbacks to developers. We can do like stuff like feature flags, like Google does it, but we will use them a little bit different to reduce the risk. And we can do like automated testing to automate repeated processes. So like testing the same stuff over and over again. That makes sense to do this automatically. So how do we do that? So usually you got like some version control. Let's call it a develop branch. And now what we do is we usually run a develop stage where you got the develop software version, and then you can test it. But that doesn't scale. That works for one developer, but not for like 100. So what we provide is like a way to branch your software in, for example, in Git. It's nothing special. But then we can create like a dynamic test stage for you, where all those legacy systems and car stuff is mocked, and you can test your product with certain test data. And if you're happy with that, we also provide you like with a dynamic stage, which is then connected to our legacy systems, like our approval car backends. And you can take like a real car and test your code with this real car. And that is very similar to production. So you need like a like an additional driving license to drive those cars, but with that you can test your software without further approval, and that's within like a few minutes. And that's a huge advantage for like product owners, where they can test their own products before we ship it to the customer 5 years later. And then you create a pull request, and we feed that back to the development branch, and then it's available for everybody. So that increases, so this improves basically the work time and also the integration time here. So now we got like those nice microservices everywhere. So everything is isolated, which is nice, but it also comes at a cost. So we got a lot of those services, and sometimes you have to change multiple services. So first we build them all individually, for example, to create a develop stage. But then when a developer, let's say he wants to change the first 2 stages, so he creates a feature branch here and here. Usually he would have to do those in isolation, so write the features in isolation and integrate them later. But then we just get the same integration problem again. So what we provide here is then we build the stuff again, and we can build you or spin a stage up for you with those 2 changed microservices. And for all the other microservices, we give you the developed version. And that allows you to basically integrate over multiple microservices very early. And this also works with dynamic stages, with like real cars if you want. And afterwards, you can also run integration tests. And if you're done, we delete the stage for you. Usually you get them for like 3 or 6 hours, and then it's automatically deleted. When we create pull requests, we do exactly the same, and then do integration tests over all services. At the end, we delete the stage again. So this is basically the same, also improves like the work time and reduces integration by a lot. Now, when we do releases, we use the same mechanism. We just branch like all the microservices, we build them, and then we deploy. So we got then a combined release over all of them, which is nice, so that we got one consistent version where we can track all the bugs, and it's usually useful during testing and quality assurance. We then got like multiple features here. For example, those 3 features: a new vehicle list, material design, because that looks neat. And for example, we can show the GPS positions on the dashboard. That's just a feature which our customers want. And now we deploy this to the approval stage, which is then connected to the approval systems. And our quality assurance people then start driving around with real cars. And for example, they could be having issues, like let's say they tested in Opera, and in Opera this GPS position stuff looks really weird and breaks all the UI. So what we can do then is like we feature flag every new feature in our release. We can then disable this feature flag and go on with testing, because otherwise you would have to give it back to the supplier or to the developers, and it would take a long time until we can test again, because this has to be removed then. And this way we can just disable it, keep the software, keeps the code there, and go on with testing, and that reduces like the integration time by a lot. And when we're done with it, we can then deploy that set of feature flags to the live stage and get this in front of the customer. And as I said, that improves the integration time. So what did I show you? So overall, like we wanted to improve the lead time, for the overall time, and we focused on like the integration time, because that's the largest part in most cases, and it also poses the most risks. So what did we show? We showed that you can basically interleave development and approval by giving all the involved people, like product owners, testers, developers, a way to test stuff early and integrate stuff early. And that increases like the productivity during the work time, and it also reduces like the integration time. We introduced like feature flags to manage risks during the approval and integration. It's not the same as Google does it, where they like roll them out over time and stuff, but we can use them just to make the testing cycle faster. So we can basically take some risks, and if it goes wrong, we disable the feature. Then we provide like the development with early integration for like with real cars, which is a huge value, so that they can. I mean, sometimes there are bugs in cars, right? The specification says it works this way, but when they test it, it doesn't. And if we do this late during the integration with quality assurance, this will break our release. If the developer tests this early, he can, in most of the cases, fix the issue early. And finally, automated testing gives us an ability to remove redundant work, because you do not have to test the same feature every time if it doesn't change. So we can automate that with all the involved parties. And that's it. Thanks for listening. That's some related work. Yeah, and now we're looking forward to your questions. Gebrauch? 20 Minuten. Das eben.
Yeah.
Here we go.
Do you want to start or should I start?
Yeah, I start.
Okay.
So hello everyone, and thank you first of all to John being here in answering questions for us. And I think it was a fantastic talk you really did over evolution. And I'll start off with a question. How long did this take for you? This sort of process, how long is the overall?
So, I mean, we are still not done, I guess.
Oh.
So there's a lot in front of us, but we started around about 3 years ago. And yeah, now we basically transitioned to mostly in-house development. So like 60-70% in-house development, and like a lot better quality, and the general lead time, how we call it, reduced by multiple magnitudes, basically.
Yeah. So please post your questions in the chat, and we take Krista Lopez first, that asks, why do you believe that lines of code per hour is an accurate metric of speed of development?
It's not. I mean, it's a proxy metric, and it's probably the best we got. It's if somebody has a better metric, then go for it. But that's the easiest to measure, I guess.
Yeah, I joke with John here behind that Ericsson had how many lines of code we could reduce in our system. That should be a good effectiveness metric, but I guess it's different. Yeah, you take what you have. That's your question. Okay. So what about this in-house code reviews Fatma is asking about?
Yeah, so basically what we did is we initially had mostly external suppliers, and initially we managed like 100 developers with 2 people. And then we got like 5 developers, 1 front end, back end, app, operations, and so on. And what we started is to form like cross-functional teams over different suppliers. So that's what we did initially. But then we also hired like internal people, so that it's basically a joint operation. So currently we are roughly 60-70% internal. At the moment, a little bit more because of like Corona budget cuts. It's more like 80-90, but we will basically go back to 60% in probably 2 or 3 months.
Yeah.
And that's very healthy. So then you get some internal input, and you can scale a little bit, but you do not have this brain drain to external suppliers, which you otherwise had. Then you depend on them, and that's often not healthy.
No, I think that's a good having some addition and learn new things and so on. So what would you say are your sort of next goal? Are you thinking more on automation, or is it quality issues, or is it just learning new skills, or what is your sort of next in line here?
That's an interesting one. What we want to do is basically to get all source code in our company into one place. So the problem is actually that we are like, I don't know, probably 100 companies. Like it's a Volkswagen group, then there's an Audi group, and there's so many companies, and then A lot of suppliers are 100% daughter companies of Volkswagen. And we counted over 100 Jira instances in the company with Git hosting. So the goal is basically in the first step to mirror all source code to one central location so that a single developer can actually look at it. Because currently it's not that way that I can look into source code for cars, for example, because I'm more on the backend side. And we want to establish basically one source code base for everybody because that helps developing software.
Yeah, so simplification is really, and not so many different repositories that needs to merge. Yeah. So
yeah,
what
even
would you
access rights. So like I do not have access to other companies. That's
okay.
also already the problem.
Yeah, I can understand that. So what would you say is the biggest hurdle you had to overcome when it comes to integration?
Like all the internal processes are based on suppliers. That's the main problem. So like even the process say, yeah, write like a document where you describe everything, then get the budget, then get the supplier, then give the contract to the supplier, and then you get back the whole product. That's what the processors think how this works, but that's not how this works in software.
So was it difficult for you to change this mindset in your company, or did you get everyone on board?